Okay, good afternoon. Welcome to Computer Science 61A, the best computer science course in the universe. That's not because I teach it, it's because of this book, which is the best computer science book ever written. And it's full of great ideas and you'll love it. People who are sitting on the staircase, there's plenty of seats sort of right over here, if you want. Okay, can you guys pass out papers and listen at the same time without reading the papers? Yeah? Okay. Let's try. Okay. Here, we'll start here. I don't know. We'll see. Sure, there's another box. Okay, here, you can start these. Back along there. And you can start these. Okay, while those are going around, I'm going to start teaching you Scheme. We'll talk about the administrative stuff later. Scheme is a programming language. It's a dialect of Lisp. Lisp, for those who don't know it, is the second oldest programming language still in use. So a lot of people think it's good for something. We're using it because it is both very, very simple and very, very powerful, which sounds like it ought to be contradictory. And one of the lessons of this course is why it's not contradictory. So powerful and so simple that today I'm going to teach you Scheme, and then we'll be all finished with that. So those of you who are familiar with computer programming courses where you spend a whole year learning some programming language, we're going to do it in an hour. STK is the particular Scheme implementation that we're using. We use it because it includes an interface to TK, which is a graphical toolkit that we will have use for later on, not right away. So this is an interactive language, which means I ask it questions and it tells me the answer. So how much is 6? It says 6. I can answer a little bit more complicated questions than that, like how much is 3 plus 5? Whoops, no I can't. Plus space. My space bar doesn't work. My brain is fine. It's the space bar. So plus 3, 5 is 8. This already will look a little unusual to you because you're accustomed to seeing that written 3 plus 5 instead of plus 3, 5. But the problem with this notation that you all grew up with is that there are so many different notations. So sometimes you have an operator in between operands. Sometimes you have an operator in front of the operand, like that. Sometimes you have the operator after the operand, like 5 factorial. Sometimes you have the operator sort of all around the operand, like square root of 2, or like 7 choose 3. There are just too many notations for calling functions, and they all really are the same thing. And all these different notations kind of hide the fact that they're all the same thing. So we only have one notation. Parenthesis, function, argument, 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 however many arguments there are. Now, you're probably wondering, if you've programmed before, why we don't at least make it something like this. And we're not going to have a good answer to that until about 2/3 of the way through the class when we start writing scheme interpreters. But the short one-sentence answer is, this makes it really, really easy to write an interpreter because the program looks just like data. And that's going to turn out to be really important. For now, just go with the flow. Okay. Function names can be made up of letters, like, here's the square root of 2. And the main thing, the most important thing, is that we can do composition of functions. So I can say, what's the product of plus 5, 9, and 100? And we get the answer 1400. So that's composition of functions. It turns out that's just about all you need in a programming language. If you have composition of functions and you can create your own functions, which is coming soon, then you can do anything, absolutely anything, which is pretty cool. And that's why we can have a language that's both simple and powerful. So some functions take different numbers of arguments, as many as you want. Like here's plus 5, 9, 100, 34, 82. And the answer turns out to be 230. How about plus with no arguments at all? 0. Somebody who hasn't seen scheme before, what am I going to get for times with no arguments? 1. Why? It's the multiplicative identity element. Yeah. Now, what if I just say plus sign, not in parentheses? What's the value of that? Error. Everybody who's saying error is wrong. It's this thing. This is not an error. This is the way STK happens to represent procedures, functions. So the value of the symbol plus sign is a function. A function is a different thing from its name. Its name is just a word. So, what's square root? That's a different function. Okay? So when I type in the name of something, I get back the value of that thing. And functions are perfectly good values. This is going to be the most important thing we talk about in the next 2 weeks, is the fact that functions are perfectly good values. They're just as good as numbers or anything else. Well, if the value of plus sign is a function, what do I do if I want the answer to be the plus symbol? And the answer is I have to quote it. I don't know if you can see that well. That's a single quote, otherwise known as apostrophe character. And I follow that with a plus sign, and I get plus. Quote, hello. Quote, bunch of stuff in parentheses. I'm a big Beatles fan. You'll see that. Okay. Who doesn't have one of those great big handouts? Who doesn't? A few people over here. Who has a great big pile of them? Pass the great big pile over that way, please. And then people can sort of grab some as it comes down. And, oh, wait, no. There's a great big pile on this side, too. Okay, so pass the great big pile back to the front. Thanks. But most of you have it. This handout pretty much answers all your administrative questions. So don't ask me administrative questions of the form, can you sign my blah, 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 or anything like that today. Because you're going to read the handout, and it's going to answer all your questions. And if it didn't, you can come and ask me on Friday. Some of the questions that are more urgent than that, I will answer out loud. But first, we're going to hand out handout number 2, which is a single sheet of paper Well, let me keep one, actually, before I give them away. Thank you. The single sheet of paper tells you who your TAs are and who your readers are and which sections still have room in them, the answer to which basically is the 8 o'clock in the morning ones. So how many people have not been assigned a section at all? Oh, great. How many people have been assigned a section they don't like? All right, that's a lot of people. All right. That's more people than we have empty spaces, period, even at 8 o'clock in the morning. So here's the deal. Those of you who are willing to get up at 8 o'clock in the morning can join that section. 3 of you can join Tuesday, Thursday at 8, and 11 of you can join Wednesday, Friday at 8. Otherwise, if you have a problem, what you need to do is convince somebody in the other section to switch with you. If the problem is you don't like getting up at 8 in the morning, too bad. Don't try to crash another section because that makes the discussions too big for discussion, and also it means we run out of computers in the lab, which is kind of a limiting factor. So if you want to switch sections, you have to work it out with somebody, and then you have to tell both of the TAs involved. Whatever you do, don't tell telebears. It'll probably drop you out of the class. But you have to work it out with the TAs. That's the answer. There's nothing I can do for you at this point because the sections are full. They're overfull, in fact. We let 2 more people in than we're really supposed to. OK. That's it for administration for now. That was the big question everybody wanted answered, right, about administration. Oh, sorry, one more administrative thing. My apologies to those of you who showed up for lab this morning and found that your computer accounts didn't work. Every semester, something goes wrong. And what went wrong this time is that they reprinted summer account forms with the old accounts and passwords instead of the new fall account forms. But I think we have that under control now, and we're going to be handing out account forms here. So anyway, I'm sorry, but your lab will meet in the second half of the week. So this is the most important administrative announcement, is that even though ordinarily lab meets in the first half of the week and discussion meets in the second half of the week, this week the meeting that's still going to happen between today and Friday is going to happen in the lab, not in your discussion room. Okay? So don't go to your discussion room, go to the lab. C50 Hurst Field Annex. There are, I believe, 4 buildings on this campus named Hurst. Don't go to Hurst Gym, and don't go to Hurst Mining. Forget what the other one is. Go to Hurst Field Annex, which is the row of trailers, basically, that's right at the south edge of campus. Yeah? Yeah, right. We'll get to that. When they pass them around, yeah, I agree. So yeah, Hurst Field Annex is on Durant, which is the south edge of the campus. Ask somebody where Pacific Film Archive is, and that's where it is. OK, back to scheme. So functions don't have to be functions of numbers. Back in high school, probably all the functions you ever saw were functions of numbers. But we have, for example, the function first. So first of the word help is the letter H. Oops. First of the sentence, she loves you, is the word she. Okay? Oh, yeah. Thank you. I'm noticing people. In this class, you don't have to take notes in lecture because this book, which you're going to get, the reader for the class, has my lecture notes in it. So the reason for that is when I was a student, I found it impossible to write and think at the same time. And I would rather have you thinking than writing. If you can write and think at the same time, fine, be my guest. But if you have to make a choice, choose thinking, because the writing has already been done for you. So first works on words or sentences. A sentence is a bunch of words in parentheses. First of 349 is 3, because numbers are words too. The letters are just digits. We also have but first. Of help is elp. And last of help is exclamation point, and but last. You can, by the way, abbreviate but first as BF. Okay. We can do composition of these functions. So here's an example. Times first of 23 and last of 45 is 2 times 5. Okay. So the big thing I told you that was missing was being able to define stuff of your own. And let's start by saying define pi 3.141592654. So now if I say pi, it tells me what pi is. If I want to know what E is, I get an error message because I haven't told it about E yet. It only knows about pi. And it knows about a whole bunch of procedures, right? The ones that are built into Scheme that we've been looking at. Scheme knows about 200 procedures to start with. I think that's right. So I can do arithmetic on pi. I can say times pi 7, for example. I can say quote pi, and that's still the word pi, just to remind you. Okay, so now we're going to define our first procedure. The notation is a little different. Instead of define, name, value, it's define, and then comes a prototype call to the procedure. So square x. When we call this procedure, we'll say something like square 27 in parentheses. When we're defining it, we say square x. X is going to be the name for the argument. So define square x times x, x. So what's square of 6? That's 36. Okay? So let's see. This thing is called a formal parameter. Parameter for short, that's just the name for an argument, the function. This thing is called the body of the procedure. It's an expression which says what value this procedure should return. Okay, side comment about terminology. What's the difference between a function and a procedure? I've been using those two words kind of interchangeably. So to think about that, look at these examples, not from Scheme, just from math. Okay, let's take a vote. Are f and g the same function or different functions? Who says same? Who says different? Okay, some of each. Preponderance of same, which is good. I like that. So these are, we are going to say, the same function different procedures. A procedure is the instructions on how to go about computing a function. So if I ask for f of 5, the calculation that I do is 3 times 5 is 15 plus 6 is 21. If I ask for g of 5, I say 5 plus 2 is 7 times 3 is 21. I get the same answer, and therefore it's the same function. But I did a different sequence of steps, and so it's different procedures. Almost all the time, I will just loosely use the two words interchangeably as if they meant the same thing. Every once in a while, it matters. When it does, I'll be careful. Okay? Okay. Okay, another administrative timeout. Did you all get the one-page handout? Who didn't get a one-page handout? This corner doesn't get no. Okay, who has a big pile of one-page handouts? Big pile of one-page handouts. Okay, people who don't have it, raise your hand. Right, send it that way. And there's a few missing in the front, so we'll get to you. They'll work their way down after those people in the back have got them. I'm going to read to you out of the one-page handout. The Computer Science Undergraduate Association runs help sessions to introduce you to the tools we use in lab, namely the Unix operating system and the Emacs text editor. They run the sessions twice. You don't have to go to both of them, just one. You don't have to go to any of them, especially if you're familiar with these tools already. But if you're going to go, you only have to go to one. Your first chance is tonight in room 310 Soda. Intro to Unix at 6:30, Intro to Emacs at 7:30. And your second chance is a week from tomorrow, Thursday, September 4th, and that one's in 306 Soda. You don't have to write it down because it's at the bottom of this piece of paper, which you're going to get. And you know, if you're new to Unix, you should definitely try to go to one of those. Okay. I'm about to hand out computer account forms. If you got a computer account in the lab this morning and up in the corner it said summer, throw that one away and take another one. If you went to the lab late this morning or just this afternoon right before a lecture, and you got one in the lab that says fall up in the corner, please do not take another one. We have just barely enough of these. Also, don't take one for your friend. We can print more if we have to, but I want to make sure everybody in this room gets one. Okay. Great, thanks. Okay. Course materials that you need. You need the book, which is called Structure and Interpretation of Computer Programs. You can get a used one provided it says second edition on it. If it's a really old used one that says first edition, you don't want it. It's by a couple of MIT professors, Hal Abelson and Jerry Sussman. Some students actually don't like this book because it's very, very dense. Every sentence that's in this book is there for a reason. So it's not sort of light, curl up in bed reading. On the other hand, all of computer science is in it. I'm, of course, exaggerating a little bit, but if you actually pursued all the references and all the footnotes, you would be getting pretty close to all of computer science. Every week, mind-blowing new ideas. So it's not going to be the kind of class you took in high school where, this week we're learning about the while loop, and next week we're going to learn about the until loop. It's not like that. Every week it's going to blow your mind. There's also a course reader in 2 volumes. The reason it's in 2 volumes is it has an aggregate cost of $43 and change, and students want to know about getting used ones. And so you can get a used volume 2. Volume 2 is essentially unchanged from semester to semester. It's the reference materials for the course. It has my lecture notes. It has the scheme reference manual. It has 3 complete sets of sample exams for the semester, and various other things that you need to read. This stuff, again, there's like a few little corrections from semester to semester, but you can get a used volume 2 and it's okay. You should get a new volume 1 because volume 1 has this semester's assignments, this semester's due dates. In this are all the homework assignments for the semester, and all the lab assignments for the semester are in here. So this one is only $10. You can afford that. And that's it. Those are the 3 readings that you need. There's an optional text listed, Simply Scheme, which is the textbook for CS3. It's sort of our zeroth computer science class for people who've never programmed before. You don't need it unless you find that you're having trouble in this class and you'd like a sort of slower introduction to the basic ideas. So don't get it right away. I hope you won't need it at all, but if you do, it's there. And I think that's it for readings. Okay, back to work. Oh, yeah. If you've programmed before in a language in which lines are an important unit of program, like this line and then this line and this line, it's not like that in Scheme. In Scheme, starting a new line is the same as typing a space. Everything you type is just as if it was one big line. What counts is those parentheses. So up here, when I did this definition, the end of the definition is the closed parenthesis that matches this open parenthesis. Now, the nice thing is, Emacs, the editor you're going to be using, knows about Scheme. Actually, I should. So I could say define, well, let me do this. And now it's indenting me to the right place underneath the define thing. And I'm going to just say first of word. So let me just show you this procedure at work since we have it. Let's look at second of So how did that work? Well, it took but first of the argument, and that gave it on the hill. And then it took first of that, and that gave it on. So second is first of but first. There we go. Okay? Okay. Why did I use WD as the formal parameter instead of spelling out word, which is the kind of thing it is? Yeah, because the word word, W-O-R-D, is the name of a primitive, that is to say, built-in procedure that I want to use. And so if I called my argument word, that would use up the name word, and I wouldn't be able to use it to mean this procedure. So would is the argument. Now if I ask for plural of boy, I get boys. Plural of computer, I get computers. Plural of fly, I get flies, which is wrong. F-L-Y-S is not the plural of fly. So we're going to have to fix this. Oh, whoops. I had both of them in here. Okay, so here's a new definition of plural. And it uses the thing that I want to show you from this example, which is if. If says, if takes 3 arguments. It says, if the first argument is true, then give me the value of the second argument. If the first argument is false, give me the value of the third argument. So if I ask for plural of fly, last of fly is the letter Y, so that equal up here, right here, is going to give me the value true, and therefore I'm going to compute but last of the argument, namely FL, and word takes 2 words and sticks them together to make a big word. So I'm going to take the FL and the IES, and I'm going to put them together and get flies. If I take a word that doesn't end in Y, like computer, then plural, well, if computes its third argument, namely word would quote S, and so I get the correct plural for computer. Questions about that? Boy. Oh, you want to know about boy. Oops. But it's okay, because you're going to fix that in lab. All right. Ordinarily, the way scheme works, here we go. Suppose you give a complicated expression like plus times 2, 3, minus 8, 1. Scheme computes this sort of inside out. So when we see a function call like this, we start by computing all the sub-expressions. So what's the value of the plus sign? Well, its value is the addition procedure. What's the value of times 2, 3? Well, that in itself, we have to go through what's the value of this, what's the value of this. But I'm going to skip those steps because they're all trivial and say we eventually end up with a 6. And then we do the same thing. Well, I shouldn't say then. In some order or other, scheme does not specify the order in which the arguments are evaluated. But we get 7. And then we call the addition procedure with the arguments 6 and 7. So the addition procedure doesn't know what expressions gave rise to those values. Well, procedures only know about values. Okay? So that's how we do procedure calls. First step, compute the sub-expressions. Second step, call the procedure with the actual argument values. So here's some more terminology. Times 2, 3 is an actual argument expression. 6 is an actual argument value. Makes sense, right? Okay, so first compute the sub-expressions, then call the procedure with the actual argument values. And then if it's a procedure you wrote, the actual argument values are hooked up with formal parameters. In this case, there was only one, but you can have as many as you want for your function that you're writing. And the argument values in order, left to right, are associated with the formal parameters in order, left to right. Okay? Basically, you take the actual argument value and you substitute it for the formal parameter in the body. So if I take square of 4, or square of plus 2, 3, or anything that comes out to 4, the actual argument value is 4, so wherever I see an x in here, I'm going to put 4, and I end up with times 4, 4, and then evaluate that. That's how Scheme does it. Except for special forms, of which there are maybe a dozen. Most of which, well, some of which we're never going to look at, that have a different evaluation rule, and if is one of them. The rule for if is that the argument expressions are not evaluated ahead of time. And that's because if is only going to evaluate the second one or the third, but not both. So if evaluates the first one, gets the answer true or false, and then either evaluates the second or evaluates the third, depending on if it was true or false, respectively, but not both. Okay? Questions about that? Yes? He wants to know, is OR a special form? Yeah, it is. You have a homework exercise that's devise a test that'll tell you whether OR is a special form or not. It's a good question. By the way, thank you for reminding me. When you stick your hand up, which I encourage you to do, I might not see you right away, and that's because they're webcasting this, and so they're shining bright lights in my eyes. And so I have to take time out from computer science to teach you a little bit of psychophysiology, which is, it's a lot easier to see things that are moving. So if your hand is up and I'm not seeing it, wave it. That will help. Okay. Next example. Okay, so this is a little program to translate words into Pig Latin. Who knows how to speak Pig Latin? Comes and goes. It's supposed to be a little kid's secret language to keep secrets from your parents, but these days it's more like a parent secret language to keep secrets from their kids. The way it works is you take a word and you take all the leading consonants and put them around at the end, and then add AY. So Piggle of the word scheme, my favorite example because it has 3 consonants in the front, is Imske. So how does this procedure work? That's our big idea for today. Oops. Wasn't supposed to happen. That's what was supposed to happen. So PL done, question mark, is a little helper procedure. And it just says, is the first letter of the word a vowel? If so, we don't have any leading consonants to put on the end. So I'm just going to stick AY at the end. So for example, if I say Piggle of Aardvark, whoops, that's not what I meant. try again. Piggle, quote, aardvark. There we go. I get aardvark A. The interesting case is, what if it's a consonant? Well, I take but first of word and first of word, and I put them together. So let's say the word is scheme. So but first of scheme is scheme. First of scheme is S. And I put those together and I get cheems. Well, is that Pig Latin of scheme? No, it's not. We're not done yet, because it still starts with a consonant. Even if it started with a vowel, I'd still have to stick an AY at the end. But in fact, it starts with a consonant. So I'm going to have to keep moving letters to the end. Luckily, I know a procedure that will take a word and convert it into Pig Latin, namely this procedure Piggle. So I take this thing that I just did on the board, which is word, but first of wood, and then I call Piggle with that as its argument. So I'm going to take Piggle of cheems. Maybe I should write this down. So I asked for Piggle of scheme. And my procedure has decided to compute Piggle of cheems. And that's going to take the C and move it to the end. And do Piggle of Heemsk. And that's going to take the H and move it to the end. So it's going to do Piggle of Eamsk. And that starts with a vowel. So finally we get Eamske. Okay? This is an example of recursion, which means a procedure that calls itself as a helper procedure. If that's new to you, then you don't really satisfy the prerequisite for this class, and you should think about taking CS3 first. If you want, you can come ask me questions about that later in my office hours or something. But that's really kind of the dividing line of people who have success in the class. If you understand recursion, you'll do fine. If you don't, you'll have trouble. OK, let me stop for questions. Any questions so far? Yeah? How would you make it print a space? OK. Thank you for asking. Don't think that way. It's not printing anything. It's returning a value. These things are functions. They return values. The value of the expression that you give to scheme, in other words, the answer to your question, is printed by scheme. But your procedures that you write do not print things out a character at a time or anything like that. They compute a value. So if the value you want has spaces in it, then it's a sentence rather than a word. And the way you would compute a sentence is you can construct it with, for example, the procedure sentence. So I can say sentence, quote, I quote by, and get a sentence. OK? Now, how many things is this sentence made up of? 2, not 6. Right? Don't think of it as a character string. This is all you people who've programmed before. This is not an array of characters. This is a sequence of words. So the pieces of a sentence are words. It's a much, much, much easier way to think about text, is in terms of its natural units, which are words and sentences, rather than unnatural units like characters and strings of characters, which only computer people know about. This business of words and sentences is the thing that made Lisp such a huge success. It's called symbolic computing. These, symbols. Words and sentences are symbols, and that's what Lisp is good at, and that's how to think, okay? Next question. Yeah? Say it again? Help with Scheme. Wait a second. Check. API. You're looking for documentation on Scheme? In the course reader, you will find the Scheme manual, which tells you everything there is to know about Scheme. And also the textbook. In terms of online help, nothing good that I know about. Yeah?
Because you'd like to present the answer in the table, is there a function that would let you do that and align all the values correctly?
So you want a bunch of things lined up. Yes. The answer is yes. But we're not going to do things like that for a while, because I really want you to, actually, thank you. What's this course about? Before I give this talk, just to make sure, does everybody have a computer? Who does not have a computer account? Are there a few people who still don't? Okay. Anybody who has any extra of anything, please pass them down to the front. Okay. Programming paradigms. Computer programming is the easiest thing in the world. Right? This is the big secret. We get paid a lot of money for doing something that's dead easy. And you know it's easy because the world is full of 12-year-old computer programmers, right? It isn't full of 12-year-old bridge builders or 12-year-old, nuclear physicists or anything. But it's full of 12-year-old computer programmers. Computer programming is easy as long as the program you're trying to write fits in your head all at the same time. When the program gets too big to fit in your head, that's when it gets hard. And the difficulty is not a difficulty in writing computer programs. It's a difficulty in controlling complexity. So computer science is kind of a misnamed field because it's not a science. It's an engineering discipline. And it's not about computers. It's about controlling complexity. And the way we do that is with the idea of abstraction, which is thinking in terms of big chunks. And a programming paradigm is a way of organizing the big chunks. And we're going to look in this course at functional, object-oriented, and briefly, that's something called client-server, and much too briefly at logic programming, also called declarative programming. These are the programming paradigms we're looking at. Right now, I really am answering your question. Right now, we're looking at functional programming. And the deal in functional programming is all you think about is values. You don't think about when things happen or first this, then that, and that. And so we're not going to think about things like what goes on what line. Your program produces a value, one single lump of information. Okay? Later on, when we get down here, we'll talk about how to format stuff. Okay? You can ask me again. Okay. We have less than a minute, so I'm going to spend it by asking again for things to come to the front. Do we have any account forms extras? Wait, don't. All right, extras, pass them down to the front. Please don't make a lot of noise yet. One, okay. It's a start. Here's a few. And here's some of these, great. And if they're extras of that other one-page handout, bring them down to the front too. If you didn't get one of those things, come down to the front and get it. And there's some here too. Good. Okay, folks, hang on. I want people to be able to hear what I'm saying. If you're missing a handout, first come down to the front and try to get one. If you still are missing it because we ran out of accounts or something, it won't be today. Tomorrow, Jenny Jones, 339 Soda, will have all of this stuff.